In this video, we're going to make some connections between the ratio work that we've been doing and percentages. So to start off with, I have drawn us a diagram here of a, maybe we could call it a tape diagram, and we're going to think about a part to whole ratio. We've done some of these before, so maybe we'll think about this as being red to the total. I'd like you to think for a minute, and I'd like you to write down what is the red to total ratio for this tape diagram here, please. Hopefully you've decided that that is a, not a 5, a 3 to 5 ratio, because we have 3 that are red, 1, 2, 3 out of 5 total. Now a percent is the same idea, except we fix the total as 100. So if we say that on this tape diagram that the whole thing represents 100, should have left more room there. If we say that the whole thing represents 100, then what would each part need to represent? I want you to go ahead and try and think about what would each box be if all 5 boxes together are 100. Hopefully you think that each one would be 20. And so that means that our percent ratio would be 20, 40, 60 to 100. Because those 3 boxes that were red in the part to whole are worth a total of 60 when we've broken it down into hundreds. So that means we could say that 60% of the boxes are red. And likewise, we can say the opposite. So if I asked you how many were yellow, we can see there's 2 there that are each worth 20, so 40% are yellow. And it's not a coincidence here that if we take 60 plus 40 and we add them together, we get a total of 100%. All right, let's try a problem. So I want to know 40 is 25% of what number? Take a minute, pause, see if you think you can figure this out on your own. All right, so we're going to solve this one using a double number line, and then we can compare and see if that's the same answer you got when you tried it on your own. And before we do that, just to make sure we understand what's being asked here, what we're saying is we have some unknown number, and that if we take 25% of it, that's like a quarter, right? Saying that this is our 25%, that much is 40. So that might help you even just figure this out in your head, but we're going to look and see how to do it with the double number line. So my first number line is going to go up by 25s. And notice that I'm spacing them evenly. I'm putting 2 spaces in between each one. And I'll go up to 100. And that's like my target, because it says of what number. So that's like when it's 100%, what's it going to be? My other number line is going to go up by the 40. So this one is going to start, with the 40 is going to line up with the 25, because those are the same, right? That was what it told us in the original problem, that 40 is 25%. Okay, but then I'm still going to go up by the same interval, so 40, and if from 0 to 40 is 40, then I have to count by 40. So 80, 120, and 160. There we go. So this shows us that 160 is, or sorry, that's not the right way to say this, that 40 is 25% of 160, which should kind of make sense with our model, right? If we had 40 in all of these, that would give us a total of 160. All right, here's a different type of problem. So in this one, we're trying to figure out what 77% of 250 is. So we've been given the whole and the percent, and we're trying to find the part. Pause for a minute and see if you can figure it out on your own. So in this one, we have some big whole. We know what that is. It's 250. And we're trying to find 77% of it. So like, I don't know, that's like a little bit more than 3/4. So we're like trying to figure out what all that is. Ish. But we don't know. So we're trying to figure that out. So like I said, the part, we don't know. The whole is 250, and the percent is 77, or 77 out of 100. All right, so on this one, we're not going to do a double number line. That 77 doesn't go in nicely to 250, so that would not be very helpful. Instead, we're going to try a ratio table. All right, so we have our part and whole table. We are going to start with the percent. So in that case, the part is the 77 and the whole is the 100, because it's 77 out of 100 is the right ratio. And we're trying to get this number on the bottom, trying to get that number to be a 250. We want the whole to be a 250. It's not a 250 right now. So let's make it bigger to start off with. Let's do times 2. That'll give us 200. And whatever I do to the bottom, I have to do to the top. So 77 times 2, that'll be 140, 154. Okay, that's closer. It's still not 250 though. But it's only 50 away, and 50 is half of 100. So let's divide by 2. See what that looks like. So that would give me 50, because I'm still working from the 100. And then 77 divided by 2 would be 38.5. Okay, so now we haven't done a whole lot of this. You have a couple options here. We could either scale the 50 up times 5. That would work. Or if it's not too confusing, you might find it easier to add these together and then also to add these together. Because you can add for ratios, you just aren't adding the same thing, right? But you can like add the whole parts together and add the parts together, and that will still work. So I'm going to do that because that sounds easier to me right now. So 250 plus 50 would give me 250, and 154 plus 38.5. Eee. That's 192.5. 192.5. So that means that 77% of 250 is 192.5, which should make sense. It's more than half of 250, right? And we look at our model, we know we're looking for something that's more than half of 250. All right, this is the third type of problem. We have 200 is what percent of 1,000? Go ahead and pause, see if you can figure it out. What's the missing piece here? What are we trying to figure out? Do it now. All right, so in this one, we know what the whole is. The whole is 1,000. And we even know that the part is 200. We just don't really know what size the part is, right? We know it's less than half, but we need to be more specific than that. So we're going to use our third model to figure this one out. And that's going to be a tape diagram. And so on this one, we know that the part is 200, the whole is 1,000. The thing that we're missing is what that actual percentage is. When I'm setting up my tape diagram, I want some number that goes in evenly to 1,000, but also in evenly to 100. So to me, that says maybe I'll count by 100s. I'm not doing this because it's percents and percents out of 100, although that is nice. I'm doing it because 100 goes into 200 and it also goes into 1,000. So if I'm counting by 100s, I'm going to need 10 of them to get to 1,000. So here's a tape diagram broken up into 10 100s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that whole thing is going to represent 100% because that's the whole. And the top part is representing the numbers. And so then this bottom part here is going to represent the percents. So if it's broken up into 10 parts, then each of these is worth 10%. These are the percents, and these are the numbers. So there's 10%, 10%, 10%, all the way across. And so then I just need to see what is that 200 representing. So if I take 2 100s, right there, that's 200, and we can see that's also 20%. So 200 is 20% of 1,000. Finally, your practice problem. So the question here is, what is 20% of 750? You need to decide which strategy you're going to use to solve. Just make sure to show some work and be ready to check this one with me. Good luck.